In this video, I'm going to introduce you to a new group of polar graphs. Here's what their equations look like. It looks like the equations of circles with a constant added to them. And we're going to look at how these two constants affect the graph. So here's this first graph, this red graph. Notice it has a loop in it, kind of like a circle with a loop in it. Notice it goes up to 8 here, and it goes out to 3 here and here, and it has a loop that goes up to 2. Now I'm going to add this one right here. This is the blue graph here. Notice it still goes up to 8. It goes out to 5 either side here. It goes down to 2, and it does not have a loop. And the third graph is the green graph. It still goes up to 8 here. It goes out to 4 on either side, and it has it touches the pole right at 0 here. So I want to point out some common characteristics here, and you might pause and see if you can notice them first. But first of all of the graphs have a maximum value of 8. Notice that there are two parameters here, the 3 and the 5, the 5 and the 3, the 4 and the 4 add up to 8. That's because if sine of theta is equal to 1, which is the maximum value it can get, that occurs at pi over 2. And so we would have 3 plus 5 times sine of pi over 2 is 3 plus 5 times 1. 5 plus 3 times 1. 4 plus 4 times 1. So that's why these are all 8 at pi over 2. Now let's look at 0 and at pi. At 0 and at pi, sine of 0 is 0 and sine of pi is 0. So that means we would have 3 plus 5 times 0. So we would just have r equals 3. So notice for the red graph r equals 3. For the blue graph r equals 5. For the green graph r equals 4. So this width here is just the first number. Now the thing in the middle here that's different here, at 3 pi over 2, which is going straight down, at 3 pi over 2 sine is negative 1. So we would have 3 plus 5 times negative 1, or 3 minus 5. That means for the red graph, at 3 pi over 2 we're going negative 2. So we're going in the opposite direction of 3 pi over 2. So this is actually a radius of negative 2 here. For the blue graph, it would be 5 plus 3 times negative 1, or 5 minus 3, so we have a radius of 2 at 3 pi over 2. And because just remember here, in polar, down does not mean negative. Negative is in the opposite direction of the angle. Well, the angle here at 3 pi over, the angle here is at 3 pi over 2. See right there? It goes down towards 3 pi over 2. So that means this is the positive radius for 3 pi over 2. Going up is the negative radius for 3 pi over 2. Okay, and then the third one, 4 plus 4 times negative 1 would be 4 minus 4, which is 0, so it just touches at the pole. So those are the characteristics of a Limacon that will help you interpreting the equation and graphing.